If we just like to add that value, then make a sum. That means sum is equal to sum sum plus I. So after that, after the series will be completed, we will see the sum. And before that, of course,
is equal to sum plus
sure. Sum is equal to sum plus, and before that, we have to initialize the sum as 0. Otherwise, the garbage value will be in the sum, and the total sum will be a mess and nothing else. So, of course, keep in mind that if we want to take the addition of any series, then the sum will be initialized with 0. Otherwise, a garbage value will be in the sum, and total will be unpredictable. Okay, so after completing this series, we will see out the sum, and before that we can use that plus equal to sign, and then sum. Let's see. So up to 10, and this will be 1 2 3 up to 10, and the total will be 65. Okay, it's fine. So in this way, there's one anomaly, and that is the case as the last term 10. After that, there is a plus sign. So what we can do is make some modification. So modification will be instead of placing plus afterwards, we can place the plus before that. That means a light modification is cout I, that's good, I is equal to I plus 1. And what we can do is, before, we can just show the one value, cout 1, okay, the initial value, okay, and then we place this plus before that, that means before I, and then initialize the sum not with 0 but with 1. That means the loop will start from I, that means the first term 1 or I is equal to 1 will be added to the sum before the loop, and we will consider cout as from the second one, okay. Then we can avoid the scenario of the last plus. Just see. So 1 2 3 4 5 7 9 9 10, but there is an 11. So what we can just modify is less than, and do it again. So is it correct? 10, then 10, 20, 10, 10, 10, 10, 10. 1 2 3 4 5. Okay, now it is okay. 55. Okay, so what we modified is that we initialize the sum with 1. That means the first term, and we show the first term before doing the while, and from the second term we use the positive sign before, and then the I value. Okay, now do the same thing. Instead of doing while, we use for loop. Okay, for loop is another pattern. Just copy the same thing. Just copy the same thing and disable this term, this block, and instead of writing while, we use for, and the condition is same as before. So what is the change? The change is till now, instead of writing while, we use for, and in the for loop, within this first bracket, there is 3 segments. The first segment is called, so just I write here, in the for part, like while, here is the condition, that's fine. But before that, there's a part for initialization, initialize, and the last part is the update of the controlling variable. Update means I plus 1 or I minus 1, whatever. So in our loop, the controlling variable is I. And so based on this logic, we will just modify the things. So the condition is in the middle, that's fine. And we are increasing the value of I is equal to I plus 1. So instead of writing in this part, okay, so we can write here, and initialization I is equal to 1. So since we have done this previously in this case, so we don't need to just keep it blank, okay? But what we need to maintain is this 2 semicolon. Okay, if you don't like to place I is equal to I plus 1 in this case, no problem. May make it as before, no problem. But at least we have to maintain this semicolon, because for the for loop, the structure is that within the first bracket, there are 3 segments. The first segment for initialization, second segment for condition, and the third segment of increment or decrement of the controlling variable. So if we do not like to use the first part or the third part as similar to the while loop, then okay, no problem, but keep it blank. Keep it blank. So initialization is done in the 10th line. Before that, the controlling or the update of the controlling variable is in the loop like while. Okay, then you can make it blank. Or if you like to update these things, you can place it in this part. Okay, so we can do it in this way. Now, see out, instead of if we follow this pattern, then see out will be now see, if we update in this case, then it will be problem means what for loop is going to do, it will at first check the condition. It will first check the condition. If the condition is true, then it will go to the loop. Okay, so it will not update, it will go to the loop. It will do the execution, and after that, it will update this value. But in our case, we update the value in this part, like while. So we will not place this thing, rather we will place here. Now the things will be like before. That means if you do the execution, it is similar to while. And the third case is do while. Okay, the third case is do while. And what is the difference between do while? Just write in different place. While, condition, then statement. For the do while, will case do statement, then while. Similar thing. And for the for loop, it will be for, then initialization, and then condition, then increment or decrement based on the problem. And here we will have the statement. So these are the 3 pattern: while, do while, and then for. Okay, but the same thing, the condition is same for this 3 part. So just make a division so that you will So the conditions are same for all these three. Statement is same for all these three, but the change is here initialization is done for the while loop. We'll do this initialization before. That means here initialization will be done here. For the do while initialization will be done here. But for the while, if we like, we can do the initialization of the controlling variable. Initialization means initialization of the controlling variable in the before part, or if we like, we can do it in within this for pattern. Okay, both are okay. So this is the change with concept to while and for. And what is the change between while and do while? So in the while, if the condition permit, then the statement will be occurred. But in do while, at first, once for the first time, the statement will occur, and then the while condition will be checked. And if the while condition is okay, then it will go to the second looping. So if the condition fails, while will not work. But if the but in the case of do while, if the condition fails, at least for the once, at least for the first time, the statement will be executed. Okay, because here the logic is that statement, then condition check. If condition permit, then again statement, then condition check. So in this way it goes on. But for while, what is the case? At first condition check, then statement. Again condition check, then statement. So here at first statement, then condition, statement, condition. So that's why for in the do while case, at least once, whether condition agree or disagree, the statement will be executed. But for the while case, no. At first condition checking, and then condition permits, the statement will continue. Similar thing is for also. For the for, at first condition, if condition permit, then statement. Again, then update of the variable, I should say, the update of the variable or increase or decrease of the variable update. Then again, condition check, then statement. Then update of the variable. Again, condition check, then if permit, statement. Now, in the for loop, we say increment or decrement of the controlling variable. But what's about in the while and do while? In the while and do while, we have to make this increment and decrement or decrement within the loop. In the do, we have to increment or decrement within the loop. But for the for case, we can have two provision. One is, if we like, we can place this increment or decrement in the for, or if we like, we can make it blank and we place the increment and decrement here, no problem. So for give us two flexibility. For can be used in similar fashion with while. Okay, so if we make this for part, if we want to make this for part similar like while, then what we can do, we can just initialize before in the for, just place condition, but beware, keep in mind that for has 3 segment. So if we make it blank, no problem, but you have to give the semicolon. Okay, otherwise it will create problem, it will show you the error. And statement, if we'll increment and decrement in this place. So initialization as while, condition as while, and after statement, increment and decrement of the variable is similar to while. So while loop and for loop is, you can make it as same. So the question is why we need to learn these 3. Okay, so if they are doing the same thing, yes, they are doing the same thing, but the fact is we generally do the while. If we do the for loop for counting purpose. That means if we give you the counting that for the 5 times, for the 10 times, for the 15 times, the things will be repeated. Repeating things will be, repetitive things will be occur. Then we generally use for loop. And while loop is just we are going to something, and if we reach a certain value, or if we reach a certain phenomena, then we will stop. Okay, otherwise we will continue. So almost similar, but precise counting is deal with for loop, and a scenario is deal with while. Okay, we will just go through several examples, then we will understand actually where to place for and where to place while. But again, while and for both are similarly used for the programmer. Okay, so again, go to this example and see uh, how things work. Now, just if we like, we can go through the our Sham series book and see the examples, how in iterations things are going. Okay, so in the first example, while using a while loop at compute to sum of consecutive integers. So what we have done here, that means we are summing the things from 1 to 10 and see the sum. Okay, so these things we have done already. So go to that example 4.2, using a while loop to compute a sum of reciprocals. So reciprocals means the opposite of the things. In this case, uh, just beware that since it is 1 by 2, 1 by 3, it is a fractional number. So it has a decimal point. So instead of integer, we will use the float or the double. So just run this, copy this program and run it in our problem. So at first, give the bounding value. Bounding value means since now the case is here we are not concerned about how many terms we will go. You are not giving the point that we will count up to 10 terms. We will count up to 20 terms. No, you are, because you don't know how many terms you will go, but you know that I will go up to some bounding value. That means our sum will be 3, our sum will be 4, and we don't know how much time we have to go to reach that boundary. We don't know. As an example, if I just give you an example that you have to have the CGPA 3.5. Okay, so and to make that CGPA, to avail that CGPA, you don't know how many hours per day you have to study. It may be 3 hours, it may be 4 hours, it may be 5 hours. So for the first semester, if you study 3 hours every day, okay, um, and your CGPA is, as an example, 3.3. So you understand that no, three hours per day is not sufficient. I have to study 4 hours. Then for the next semester, you studied 4 hours and you get 3.6 CGPA. Okay, it is a better CGPA, but I need only 3.5 CGPA. Then for the third semester, you study 3.5 hours regularly, and after the semester, you achieve 3.5 CGPA. So you don't know how many hours a day you have to study, but your goal is to achieve a certain CGPA, and for the CGPA, you have to uh, make and try your best. So in this case, you don't know how many hours you have to study. So this is the case for while. So in while, the condition is you have to reach a bound, but to reach that bound, you don't know how many times you have to iterate the loop. So this is the case for the while. But instead of while, if it is for, then you have to, or generally you will precise that I will run that loop for 100 times. I will run that loop for 200 times. So in this case, for will be better. But if we don't know how many times the loop will go, but we know that we have to reach a something goal, something boundary, or something, then while is better. Okay, because here the counting is not the main issue. If the counting is not the main issue, while is good. But if counting is the main concern, then we have to go for loop. So in this case, okay, so we will sum the result, and it should be below that bound, not it will cross the boundary limit, and the sum will go on. And what is the sum? Sum will be 1 divided by I. Okay, what is the value of I? I will be 1, then I will be 2, I will be 3, I will be 4. And again, here we see this, that pre-increment. Pre-increment means, since you see the I is equal to 0. So at the initial case, sum is equal to sum plus 1 divided by what? 1 divided by 0. No, it is not 1 divided by 0, because it is a pre-increment. Pre-increment means at first I will be incremented, and then pre-increment here, just think pre-increment, pre-increment, it means that at first I will be incremented, then the incremented or the new value of I will be used for this statement. So this is the case. But if you make the opposite, that means if you write post increment, what will happen? At first, the previous I, that means 0 will be considered for this calculation, and after that calculation, I will be incremented. After that, I will be incremented. So in this case, we don't like that. We don't like something 1 divided by 0, because we need to increment the I. Okay, we need to increment the I previously, and then the new value of I will be considered for this calculation. So that's why here we use pre-increment. And another thing is that here in this while loop, we have only one line. We have only one line. That's why we haven't used any scope or any second bracket. So beware in mind, if in the loop or in the if the line is only one line is under that loop, then you can omit the second bracket. Otherwise, if there are several lines, you have to use that second bracket. But my personal recommendation is, whether it is single line or whether it is multiple line, please give second bracket. It will give you, it will be more precise, and it will help you to avoid some errors. Okay, so it will be easier, it will be easily visible to you and to the teacher. That's why I suggest, whatever, if there is only one line or if there are several lines, you have to give this second bracket. But for only one line, I suggest you to give the second bracket. It will be easy for visualization. Now, just run this code. So in this case, actually, you will not see 1 divided by something, 1 divided by something. It will just show you the final result. Okay, so if we run this program, I hope there will be no mistake, and enter a positive boundary, positive integer, that means 4. And for 4, the sum is the sum of the first 31 reciprocal is 4.02, near to 4. Okay, they are near to 4. So we have to iterate this loop 31 times to reach that boundary positions. And if you like to see the series, then you can write a line like C out, and then 1 divided by. So you can just make like this, 1 divided by 1 divided by that number. That number means I. Okay, you can place I, but it will be after that, after the initialization of I. So what you can do, like previously, C out, and then you place 1. Okay, and then just do it, and here it will just show like plus, then 1 divided by that new I. Okay, so in this way you can continue, and after that the sum of the first reciprocal is, you can see the result later. So in this way we can show the series. Let's see, just consider that 2, and what will happen? 1 plus 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. The sum of the first 4 reciprocals is what? Is 2 point something. Okay, so you can just avoid these things, and again we run this program, and terminating total summation will be near to 3, and then 1. If we just say this is 1 plus 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, up to 1 by 11, and after 1 by 11 the sum of the first 11 reciprocal is 3.01. It is almost near to 3. So in this way you can just implement the second example of the Shom series book. Now we go to the third example. So using a while loop to repeat a computation. So why you are repeating a computation in which way? So in this case, just see, this program prints the square root of each number input by the user. It uses a while loop to allow any number of computations in a single run of the program. So in this case, your loop is controlled by the input variable. Input variable is what? Just as an example, you want to play a match. Okay. After the first match, if you have time, we can play a second match again. If we have time, or if we like, we can play third times, we can play 4 times, and if you don't like, we can quit after any match. So you have the provision, you have the freedom to play a game several times. It will be 4, it will be 5, it will be 6, it will be 1. Okay, so in this case, in this example, what happens is that you are giving a number, and the program will, or in the loop, the square root of that number will be shown, and after showing that number, the program will ask you, do you want any other number to be calculated for the square root function? So what is the logic? The logic is your value must be greater than 0. Your value cannot be negative. So this is shown in the first case, that means enter a positive number. So if you want to continue your looping, or if you want to continue this program, you will give positive number. But if it is negative number, then you can avoid. Okay, you can escape, or you can stop that looping by putting a negative number, because the condition is that your number will be greater than 0. But or if you give 0, it will be stopped. And it is suggestion, the suggestion is given here, enter another positive number, or if you want to quit, just press 0 or any negative number. Okay, so this is the logic. And in this logic, again, I say in this example 4.3, what is the new idea? The new idea is that you can control the loop by giving a value within this loop. So in this loop, you are giving the value of x, and based on that x, the loop will continue. So what generally we do is that in the previous example, we give a boundary value and the program will continue, will continue, will continue. And when the boundary value will be reached or crossed, then the program will be terminated. But in this case, you can terminate the loop in any iteration while you like. So the loop is controlled by the input value within this loop at any time. So here the boundary is not the issue. The issue is whether you like to continue that loop in that iteration, in the next iteration or not. So the loop, the idea is similar. What is the basic idea of loop? Loop is, or the iteration is doing a similar things for several times, but based on the condition. And the condition will be visualized. Condition will be placed in different way. You can place the condition before that. You are giving a verdict. You are giving a commitment, or you are giving a condition that we have to go certain limit before the loop is starting, or within this loop you can make a decision that we don't like to continue. So in different way we are playing with the loop, but the main idea of loop is if the loop will be executed, you will do the, it will do the similar things. Okay, so now just go through this example. I think we don't need to run this, for example. I hope you understand these things. Then terminating a loop. So here the similar thing. In the previous example, that means in the 4.3, we are giving a condition. Okay, and based on that condition, the loop will continue. But here the condition is true. True means doing a loop all the times. True means 1. So if you place true, then the question is the loop will continue for eternal time. The loop will continue for eternal time, but it can be, because the world will not continue eternal time. There will be doomsday, or that we say in Islamic terms, that the Qiyamah will come, and the world, this worldly affairs will be at end. So a loop cannot be eternal time. It will not run eternally. So there must be some stopping criteria. But then if the while, within this while, if our condition is true, true means it will run eternally. Okay, infinite times it will continue. So we need to stop that loop in certain conditions. So if we do not place the condition, in this part, then we have to place the condition within the scope. Within this scope means within this second bracket. And what is the condition? We place the condition using if. So we have to then use an extra if. Instead of doing I is greater than n in the while loop, we can place within this loop, but we have to use extra if for that. So if I is greater than n, then it will break. Break means the loop will stop. In simple word, break means loop will stop. So terminates the loop immediately if our I, this means this I is incremented. If I is crossing the limit of n, then the loop will stop. So again, in this book, all the examples are not difficult, easy thing, but in each example, we are facing a new concept. Okay, so here we are giving a boundary value. In this case, we are placing a condition, and the condition will be satisfied or based on the value we'll give within this loop. In this 4.4 example, we are placing true. That means it is eternally true. The loop will continue infinite times, but infinite times is not a pragmatic issue. It cannot be practical. So we have to stop that loop within this scope. We place another condition, and the condition will be placed using if. And if the condition will agree, then the loop will break. The loop will stop. Break means the loop will terminate. So in this way, we can place a condition, and based on that we can break the loop. Okay, now a famous program, Fibonacci numbers. This is a common problem in every books or in every programming platform. This example is shown, and why this is an important thing, because it will uh, make a famous series, and in this case we are updating several values. So what Fibonacci number is? Fibonacci number is that a number is nothing but the summation of previous two numbers. So this is the logic. Okay, so from which number it will start? It will start from f0, and that is 0, and f1, that is 1, and f2 will be f1 plus f0. So if we like to write these things, so it is f1 is equal to 0, then f at first f0 will be 0, f1 will be 1, and f2, from that f2 the normal rhythm will be like f2 will be f1 plus f0, that means the previous two. Again f3 will be what? f3 will be f2 plus f1, like that. f4 will be what? f4 will be f3 plus f2. In this fashion the series will go on. Now the question is, up to how much you will go? So in this way you will continue. In this way you will continue, but for how many times you will continue? So you will continue up to fn till fn will be less or equal to a boundary value. Up to that you will continue. Okay, so if you calculate fn and that is over the boundary, okay, or that will cross the boundary limit, then you will stop your looping. You will stop the loop, and that you will in this program. So at first here another new thing is that instead of using integer, here the book uses long. So long integer is keep, or the long integer will keep a bigger range. Okay, so if your integer is 4 byte, long is 8 byte, and long integer is 16 byte, like that it goes. So instead of keeping integer, if you use long, then your range will be bigger, and if you use long, then it will be more bigger in range. Now at first you have to initialize that f0 is 0 and f1 is 1, and your loop will continue from f2. So what is f2? f2 will be the previous value, f0 plus f1. Okay, and if your new value f2, if it crosses the boundary, if your new value cross the boundary, then it will break. Otherwise you will show f2, and what you have to do, you have to update this value. You have to update this value. What why? Because after f2 what will be counted? Just see, if I just copy this thing and I write in this part, you will understand that. So if just see, we have counted f2, and after f2 what will be the case? It will be f3. So we cannot all the times write f1, f2, f3 here all the times. We have to update the value. How we will update the value? Our f1, our new just right here, our f new, actually it will be f f previous plus f underscore previous. I should say in this way. It will be f new will be f previous plus f previous. So now our f previous is, if it is considered, if in this f new we place the value as f2, and instead of f previous we are keeping f1, and instead of f previous we are keeping f0. So what we need to do, we have to update this, and after calculating how we will update, our f0 will be f1, our f1 will be f2, and in the next loop our f2 new will be the previous what? Previous f1 and f2, which is saved in f0 and f1. So we will write f0 plus f1, because our f0 is keeping the value of f1 and f1 is keeping the value of f2. So f0 and f1 is nothing but the previous two. In this way we can say that. So just see here. So our f0, so the idea is what? Idea is f1 is a term which keeps the previous one. f0 is the term which keeps the previous one. Okay, so in this fashion, for the next new f2 will keep, we will the addition of previous one and previous one. So we have to update our new value, and we have to update the previous one and the previous one. So in this fashion it will continue. And up to how much? So if our new term, if it crosses the boundary, then we will break. So if we like, we can just write this program in our way, so that we can see this term, and we'll understand this, how the things are going, how the values are updated. Just write the same things in our own way. There are lots of programming example, okay, but the fact is, if we understand 5 programming examples in a clear fashion way, then we can solve the others. So what, because in our shop series there are lots of problems, and if you take another books, there's a lots of problems, but you can solve all that one. So what we learn, what we solve, just think it, how the things are going on, and practice as far as possible, not beyond your limit. You cannot go beyond your limit, we don't like you to, but do practice regularly and visualize the problems that we are discussing. So just write it Fibonacci number. Someone says it is Fibonacci. Somebody says Fibonacci. Okay, so but the sound is Fibonacci. So at first, so we long, it's a boundary value. So just consider that boundary value is 100, 200. Okay, and we have 3 variables. The variables is long f0, that is 0 initially, then long f1 that is initially 1, and long f2 which is we know that f0 plus f1. So this is the equations, and now do the loop while your f2 we can write in this way: while our f2 is less than boundary, if our f2 is less than boundary, then we will continue, otherwise not. So this is the case. Okay, so you can just show the value cout, and in every calculation, if you like, you can show that cout our f0 equal to f0, and in the similar fashion you can write f1 is what? F1 is this, it is your f1, and f2 is f2. Before doing f2, we have to calculate our f2 is equal to what? Okay, already we calculate for the first time. So f2 is equal to f0, f1, and it will be f2. F2 is that. And afterward, what you are doing, you are calculating f2 for the okay. So this is the first part. It is the completion of the first round. Okay, so you can just place here. Okay, this is the completion of your first round. For the second round, this is the update round. So we should keep here. This is the update for next round. We should say update for next round. So what is the next round? The next round is that your f1 will at first your f0 will keep the value of f1 for the next round. Your f1 will keep the value of f2. Okay, and then what? Then your f2, then f2 will what? The f2 will be calculated. Okay, so I should say here, it is better here, f2 equal to f0 plus f1. I should say here f2 is equal to f0 plus f1, and that will be f2. F2 will be calculated, and after that, for the next update, f0 will be f1 and f1 will be f2. So in this way, we will continue. So this is the logic. This is the logic the program will go through. Just now run and see whether it will work. Include IO stream. What is the error here? Include IO stream.
The spelling mistake maybe. Sir, A missing is.
Include IO stream. Where? Which one is missing? IO stream.
The IO stream, sir. STREAM.
REAM. Oh, okay. Yes. Okay, so the program will continue like, just see, f0 is 0, f1 is 1, and f2 is 1. Fine. f0 is 1, f1 is 1, f2 is 2. f0 is 1, f1 is 2, f2 is 3. So here, just see, 0, 1, 1, 1, 1, 2, 1, 2, 3, 2, 3, 5, 3, 5, 8. 8, 13, 21, 13, 21, 34, 21, 34 means 51, 55. So in this way, it goes on up to what? Up to the limit. The limit is 100, 200, and just see. So here 75,000. Okay, so here it is 10. It is 100,200. So our limiting value is 100,200. So before it is 75,025. It is okay, but this value is 121,000, which is beyond the limit. So after that, the program stopped. Okay, so now the question is, if you like, if you say that if the boundary is crossing that limit, we will not show. So then for the more precision, so then instead of writing this condition, in this case, you can just place here, true. And after calculating f2, you say if f2 is if f2 is greater than bound, then you can just write here C out. You can just say we have reached the boundary. We have reached the boundary. That means what? You can say that means our f2 is equal to f2, then you can say greater than which value? Your boundary value, boundary value. And after that, so you can write, so we have to terminate the program. If you like, you can say that. Okay, and since you are terminating the program, you will write break. Okay, so after break, the program will be terminated. So this is the way you can, if you like, you can write. It is not mandatory to write several things. You no one actually asks you to give explanation. Okay, but if you like, for visibility or for clear understanding, you can write. But it is in the program. But in the exam, please don't write something which is not asked, because in your exam the time is very limited. So you shouldn't write something extra to make it more visible, make it more clear, make it more fancy. Please don't do that, because you don't have the time. Okay, you just in the exam, you just read the questions, you just precisely you make the point what are the variables that I need, the minimum variable that you need, you keep those variables, and what are the calculations that I need to do, you just do that calculation. Don't make it more C out or C in to make the program more fancy or more lucrative. No, you don't need to. In your free time, in your leisure time, in your home, you can practice, you can make it more easy, more fancy, but don't do it in the exam, because you don't have too much time. Okay, so these are the comments that make the program more easily visible. I can do it in the practice time, but not in the exam. Okay, so just write this program and see again. Just see again. So here again, that means f0, that f2 is 75,000. It is still now less than, but after the next iteration, when we want to calculate this, here we have reached the boundary 1,21,000 or 121,000, which is greater than this value. So we have to terminate this program. Now it is more easily visible to everybody actually what's going on, why we quit this program. So this is a good program just for understanding several things. And after that, here you see the exit zero. Exit zero is a function. We know that if we want to terminate a program, we have to terminate a program. We just at the end we say return zero. But if we want to do something in the middle of the program, we have to terminate that program at that point. Okay, so then we use this exit zero. If we like return zero, no problem, also it will work. So exit zero is within the library cstd lib. Again, keep in mind, exit zero is a function, it is within cstd lib. So if you want to use this exit zero means, again I say, exit zero means you have to shut down the program immediately. Then you will write exit 0. Again, just in the same program, if boundary f2 is then boundary, just write exit 0. Just exit 0. Okay. So what it will happen, just if the boundary f2 is crossing the boundary, we will not see anything. We just hear exit 0. The program will shut down at that point. Okay. At that point, the program is shutting down. So if we want to run this exit 0, probably it will not work, because exit 0 is a function. Exit is the function which is within the CSTD lib. So we have to add that probably. Okay, now it works, but in the previous versions, actually, exit 0 will not work with the C++ in normal fashion. We have to use CSTD lib. In the what we discussed in the previous day, lecture 6, that rand function is generally is within this CSTD lib, and we have to call that function. But nowadays, random is within the main library of that C++. We don't need to mention that. Okay, so this is the improvised version. Again, I just want to repeat here settings. In these settings, in editor, not in editor, it is in the compiler. It is in the compiler setting. You will see settings compiler, and in this compiler here, just see here, there's a lots of versions of C++. GNU C++ 1998. Okay. Then C++ 11, 2011, C++ 14, 2014, C++ 17, 2017. So these are the famous version of C++ compiler, because every 6 or 7 years they changed some upgradation of C++ compiler. That's why. So you have to, if you want to make your program in which compiler version. So in a general way, we generally use C++ 11. Generally, we use GNU C++ 11 by default, probably, as I know. And in some cases, some compiler by default, this IDE initialize C++ 14. In some version, it is C++ 11. In some version, it is C++ 14. So if you like C++ 17, then you have to check mark that. So that version will be enabled. If you like the previous one, 98, then you have to click that 98. So just keep in mind. Okay, we don't need to go to details because we are not a serious software developer or programmer. We are just now at the elementary level. So by default setting is C++ 11 or C++ 14. Generally, we don't need to bother about that. We just continue. Okay, but keep in mind that in the future, if you want to deal with C++ programming language as a professional software developer or software engineer, then we have to consider in some aspect these versions. Okay. Now we understand that exit. Okay, just run this exit 0. So exit 0 works. Okay, again, just we see, but again, we can take the boundary value. Instead of doing this long, we can just ask user cout that please enter the boundary value and what, see in bound. Okay. Again, we can place user can do a mistake. Enter the uh, enter the positive boundary value. I should say enter positive. Enter positive boundary value. Enter positive boundary value. Okay. And user place a boundary value negative, then it will be a mess, because Fibonacci series deal with the positive number, not with the negative number. Negative boundary value is invalid in this case. So what we have to do is give a checking. The checking is like if boundary value, if this bound is less or equal to 0, if your bound is less than equal to 0, you can write cout. You have put but you have entered wrong boundary value, and then program will be terminated. you have entered wrong boundary value, so program will exit. Program will exit, and after that you call that function exit 0. So in this way you can control the program again. So if I run this program, and if I place the boundary value like 3, 4, 5, 6, 7, it's fine, or 8, just like this, it's fine to place this boundary, and it is no problem. The program will continue, and the program will shut down, because after 31 it will be, our boundary value is what, 34, 345,600 something, 345,000, and we already reached 370,000, but after that it will be more than that. That's why program is terminated. That's fine. But if we place a negative boundary value, as that means this one, so it is not a valid boundary, and again say you have entered wrong boundary value, program will exit. Program will not calculate that Fibonacci number, because there is no provision you are giving the program to calculate. So in this way, we can control the input of given by user. So if it is wrong, then we can stop the program, because otherwise it will be miss. And okay, so I hope if you have any questions related to this